Today, I'm here to talk about one of the world's leading causes of death. It takes away your memory and your ability to think. And in the advanced stages of the disease, you lose all sense of time and space. These are the symptoms of dementia. And in Australia, more than 350,000 people are living with dementia. And it's not something that old people just get. It can be due to a pathological disease that causes your neurons in your brain to die. And one of these examples is Alzheimer's disease. Up to 70% of those living with dementia have Alzheimer's disease, and it's actually the second leading cause of death in Australia. And yes, aging is a risk factor. However, we're going to see more cases of Alzheimer's disease due to our aging population. In fact, by 2050, it's predicted that more than 21% of the world will be aged 60 and above. Currently, more than 40 million people in the world are living with Alzheimer's disease. So why are these numbers so big? This is due to the ability of humans now able to live longer. But this wasn't always the case. Back 30,000 years ago, the Neanderthals only lived to an age of 30 years old, where the leading causes of death were things like hunting accidents and malnutrition. Now, fast forward to the 1800s, the life expectancy then increased to 40 years old, where diseases such as tuberculosis and scarlet fever were the leading causes of death. Now, during this time, medicine and science was able to develop diagnostic tests and treatments for these diseases. So with better healthcare and better lifestyles, the life expectancy then increased to 70 years old in the 1900s. And now today, in the 21st century, we are now living to 85 years old. However, we are now seeing a new set of disorders. Living longer has seen high incidences in cancer, and perhaps maybe not too surprisingly, a decrease in mental function and mobility as seen in neurodegenerative diseases such as Alzheimer's disease. These are the 21st century health problems that medicine and science now face, and these are the statistics. But what happens if that one person is you? Who are we without our memories? Imagine losing your memories. Without them, we lose ourselves. Or take it from the carer's point of view. It's a truly devastating disease to watch. So terrible that immediate family members who have Alzheimer's disease in their family are concerned about their risk in developing the disease too. Those that have heard about our research has contacted us in order to be part of our research and studies. And this is one of the quotes from our study participants. My mother had the disease diagnosed at age 56. As I am now at that age, I have a personal interest in the likelihood of me developing that disease. So unfortunately, we don't have a cure for this person. However, this person still wants to know. Maybe it's for their family. Maybe they want to change their lifestyles to prevent the disease. Or maybe they want to tick off items on their bucket list. So let's talk about how my research is going to help these people. So a little bit of science to begin with. Alzheimer's disease is caused by a toxic protein called amyloid, and it accumulates in the brain where it starts killing off the neurons in your brain. In time, this starts to destroy the communication between neuron to neuron. And these amyloid plaques, they're like plaques like rust on a car. So over time, this destroys the communication that occurs in your brain. And we now know that it takes about 10 years for that toxic protein to build before the appearance of symptoms, and the symptoms worsen. But of course, we also know that patients only go see their doctors when they experience symptoms, by which stage the toxic protein is at a level that's too high for drugs to clear. So the general consensus is that we need to treat patients earlier. But in order to intervene earlier, we need a test to diagnose the disease earlier. So what we've been able to do is to develop a blood test to detect the disease earlier before symptoms arise. However, it's quite difficult to diagnose a brain disorder. That's because the brain is a difficult organ to access. So you might be thinking, nah, not another blood test. But the technology behind this test was created by adventurous scientists, the 21st century scientists. And I'm finding during my postdoctoral training that in order to solve complex problems, we need to be multi-skilled, not only in the area of our specialty, but across all different specialty fields of science. So today, I'm also feeling that as a scientist, it's a very creative process. We brainstorm ideas, we develop ideas, we try and make them happen, and this is driven by curiosity. And even though that's just me in the photo, I have a huge collaborative team of people behind me. And some of them do look like Doc from Back to the Future, but most of them do look normal. So, in order to work in a collaborative team, we need to be good communicators. Scientists like to hide in the lab. But we need to be better communicators so we can explain our research to the general public, especially those that make decisions against healthcare, so they can identify which discoveries need to make it through to the hospital bedside. And this photo here represents to me where science is heading. Science in the 21st century is now merging with IT, technology, and engineering. And back in the 1990s, it actually took a huge scientific team to decode the genetic code of life, your DNA, what makes you you. And it cost them $3 billion. And now today, with this little chip that I'm holding, I can decode and determine your genetic makeup in 2.5 hours for about $1,000. So this opens up the possibility for not only screening for Alzheimer's disease, but also every other disease and condition. It also opens up the possibilities for personalised medicine. So you're probably wondering what I put on these chips, and it's not chicken salt. So it's not actually blood either. It's what's in the blood. Scientists have now discovered that cells can release cellular particles into the bloodstream. And these particles are called exosomes. They're very small, nano in size. They're about 100,000 times smaller than a cell. We once thought that these exosomes was a way to remove waste out of a cell, but now we know that it works like an internal postal system, where the exosomes are like parcels, and they contain biological messages that can be passed from one cell to another. So for example, pretend I'm a cell, and I release an exosome full of goodies, for example. It travels through the body, through the bloodstream, and a recipient cell in a distant part of the body accepts it. It takes the delivery, and the contents of the exosomes gets emptied into the recipient cell, and it can change the behavior of that cell. So in humans, the contents can be good. They can be survival factors. However, in a sick person, they can be toxic factors. And my research involves the profiling between healthy and sick exosomes. And by doing this, I can determine the factors, in particular the genetic factors, that are associated with Alzheimer's disease. But you can see I can do this for every other disease and condition. And we also aim to understand how we can live longer free of dementia and cancer. But the applications of exosomes is endless. What we can do is hijack them in transit, package them with different beneficial factors like therapies, readdress them and send them off to the affected area, such as the brain. We can also change their composition so it's the same as the patient in order to avoid rejection. It's an exciting time for the 21st century scientist, and the next breakthrough is only around the corner. Thank you.